Hi, welcome to Data Science class. This is Vivian here, and today we will start talking about machine learning. Machine learning is one of the important part of data science, and as a data scientist, you need to understand how machine learning works. And to start with, let's see what machine learning actually is. As the definition goes, or in the simplistic form, machine learning is a process where computers, which are machines, discover how they can perform tasks without being explicitly programmed to do so. So what do you mean by explicitly programmed? So for example, if I want to add two numbers, I will write a code where I will give two numbers and say add these two numbers. If I want to run a function, I will run functions. If you want to add some logic, you'll add some logic, and whenever you get an input, you do something with that input programmatically and give an output. Now with machine learning, you don't have to do that. There's algorithms written that do it, that kind of teach the computer. It's more like you give two numbers to the machine and it will automatically add it and give it back to you as output. It's not that simple, but some of the applications for machine learning are more like traffic predictions. You give a machine data about 1 year of traffic conditions in LA, it will tell you that there is traffic or not. That doesn't need a scientist or anyone to tell you predictions in LA, but that's what it does. Similarly, face recognition, you have probably seen different photos applications which does face recognition for you. You give it multiple images and then it will kind of recognize a pattern and then tell you that this person this is the face that belongs to a person, and do you want to tag them accordingly. Sentiment analysis, what are the customers thinking? Really good about your company or bad about your company. So that's sentiment analysis. Online fraud detection, email spam, malware filtering, virtual personal assistants like Alexa and Google, they all use machine learning behind the scene because you can't actually write code to predict every single thing that happens, or a user is going to ask a virtual personal assistant. You need to be prepared for it. So you have to kind of teach the machine of what it is. Now, what are the different categories of machine learning? There are three basic categories and everything kind of falls under that. First one is supervised learning, second one is unsupervised learning, and reinforcement learning. Now let's look at what these mean individually. So supervised learning is more about where you have data with as it says, clearly defined results, output is provided. So in this case, what happens is you give the system a set of data which has input and output. You kind of train the system. So it says at the bottom in the image where it says you provide the inputs, it trains the machine by the inputs that you provided, and you get the outputs. What you do is, let's say you take a million rows of traffic information at a particular city and you provide it to the machine and tell them that this is the time where there's traffic and this is the time when there's no traffic. And next time when you ask the machine at 5 p.m. on next Tuesday, so you're asking on the future, what will be the traffic like? And it will look at the previous patterns and accordingly guess what it is or predict what it is. So it says makes machine learn explicitly. Your direct feedback is provided. So when you train the machine, you know how the output looks like, and check with the existing data and see if it falls in that particular category and is right or not. So when you're training the machine, you have all the inputs and the outputs. It solves classification regression problems. So in classification, it's more like discrete information. For example, it will say true or false, or it belongs to a particular category. If you give it, let's say, a food item, it will tell you if it's a fruit, if it's a vegetable, it's meat. So those are discrete information, so it can classify things. Regression is more like you can predict a set of items. For example, you can give input as real estate values in different zip code, or you can give medical information of different patients, and accordingly when you ask if you ask for a particular zip code, what is the price of a particular square feet apartment, you can actually predict based on the previous information that you provide. So that's what supervised learning solves for you. Next one is unsupervised learning. In this, you don't have any labeled information. You just give data to the machine and it makes sense out of it. For example, I can give a machine a bunch of data about traffic and it will make sense out of it, saying that okay, this is traffic in LA, this is traffic in DC, or it can kind of say, oh, this looks like traffic at a particular time, this is traffic at particular other time. Or you can give the machine a bunch of different products and it can tell you if those products are electronic products, if they are house products, if they are some items that you use, some for example bicycles or cars. So it can give you different information based on the data you provide. You don't have to specifically label the data that you provide. It identifies structures and patterns in the data, so it looks at all the different data that you provide and accordingly sees what is common in them. Evaluation is qualitative or indirect, so you can't actually figure out if it's doing right or wrong because you're not actually teaching the machine anything. No prediction of specific details, so as I said, there's no trained information that is provided. As and when it gets more data, it can actually kind of create clusters and tell you what the data is, and accordingly in future if you give something to it, it will classify it or it will put in a particular cluster and tell you what it is. So that's unsupervised learning. Next one is reinforcement learning. In this case, it's a reward based learning where you give an input to the machine and see what it gives you as output, and if it's something that you like, you tell the machine good job. If it's negative, if you don't like it, you give it a negative rating. So this learns based on positive and negative reinforcement is more on how the machine performs at the output and what as a user is your feedback. So you kind of give feedback to the machine and it accordingly decides in future, because it wants to get more positive feedback than negative, so it will accordingly learn based on experience. So the main goal of the machine is to maximize rewards, so it wants to get more rewards based on the inputs that it provides and the output it gives you. So those are the three different categories or classification of machine learning, and we'll look at in more detail in the next section.